To get us started today, we're going to have to write down this long rule for dividing decimals. So make sure that you're on the 3.4 video notes page to write everything down on. Alright, so the rule for dividing decimals is that you have to have the divisor, the outside number, must be a whole number, okay? And remember, a whole number means no decimal. Okay, so we got to do whatever needs to be done to make sure that outside number doesn't have a decimal. Okay, then we're going to move the decimals equally for both numbers, the inside number and the outside number. The decimal goes straight up. I always say it floats to the surface. So that is our rule for dividing decimals. So go ahead and write that down. Alright, so example 1 says we are going to divide. We're going to divide decimals, and then, like, it's always good practice to estimate to check our answer. So, but before we do that, I want to ask you a quick question here. What are my rules for integers? So, what are the rules for same sign and different signs when we are dividing? Sorry, it is storming outside, so there's going to be a little bit of background music. So when we divide and have same sign, the answer is always going to be positive. When they are different signs, the answer is always going to be negative. Okay, so we're going to have to use that today, and remember to check that when we are done with our dividing. Alright, off to the side here, I've written down our first problem. We need to take 13 and 3/10 divided by negative 38 hundredths. Okay, so we need to set this up with the box. Alright, so 13 and 3/10 divided by goes inside the box. And then the number you're dividing by goes on the outside. So we're trying to figure out how many 38 hundredths go inside of the 13 and 3/10. The first part of the rule says the outside number, the divisor, must be a whole number. So right now it is a decimal. So to make it a whole number, we have to hop 2 times because we want the decimal at the end of the number, on the right side of the number. So I had to hop 2 times for my divisor. And the next part of the rule says move the decimal equally for both numbers. So since I moved this twice, I have to move the other decimal twice. So 1, 2. So we're going to hop 2 times on the inside. So our decimal's at the end. I have this empty spot here, so that's a good place for a 0. It's a placeholder and doesn't change the value of our number. Next, the decimal goes straight up. Okay, it's going to float to the surface. Okay, has a low density. It floats to the surface. Alright, so now that we have all of our decimal rules followed, I like things to be neat and tidy, so I like to rewrite my problem. So, decimal, and now we have 1,330 divided by 38. 38 doesn't go into 13, so we're looking at the 133. So since 38 is close to 40, I don't want to get, how do I guess how many times it goes in there? I'm thinking of 40, so 40 is 1, 80 is 2, and then 120 would be 3. So I'm going to start with 3, so off to the side, 38 times 3 is what? 114. I think that's going to work for us, so I'm going to put a 3, subtract 114, so 3 is too little, so I have to borrow. So 13 minus 4, 9, and 12 minus 11 is 1. So bring down our 0. Now we're going to divide into 190. So it ends with a 0, so should we be hopeful? Let's try 5 and hope that it works for us. So 8 times 5 gives us 40, and 5 times 3, 15, plus 4. All right, we got 190. So if we plug in a 5, 5 times 38 is 190, and we have no remainder. So that worked out well for us, and we got a positive 35. Or is it positive? Let's take a look. We have a positive divided by a negative. So since we have different signs, we're going to have a negative quotient. So it should be negative. Let me rewrite that. Negative 35. Boom. Okay, before I let you try one on your own, I just want to kind of recap everything. Remember that the first number is the number that went inside of the box, and the second number is the number that went outside of the box. And also, don't forget your integer rules. And we hopped 2 times on the outside, therefore we had to hop 2 times on the inside. So there's a lot of rules to keep straight there. So now it's your turn to try it on your own. So let's solve one. You should have the whole bottom half of the page to try this. So let's take negative 3 and 78/100 divided by 4 and 2/10. Okay, so set that up and divide it out. Alright, hopefully it didn't take you too long to find that 9 actually went in there evenly with no remainder. But we have a negative divided by a negative again, so our quotient is negative 9/10. Good job! Alright, before we get started with our U-Pick question today, I want you to look at this formula that I wrote down for you. If you've never seen it before, it comes in very handy when you're solving problems like this. The distance traveled is always going to equal the rate that you are going times how long you were going. So distance equals rate times time, which mathematicians, being lazy, just made it d equals RT. Growing up, I always thought of this as the dirt formula, because when I look at that, I see the word dirt. So that's how I've never forgotten it, and it's come in very handy. So write that down so that we can use it on our problem today. So example 2 says Mount McKinley, which is in Alaska, is about 3 and 848 thousandths miles high. If a mountain climber can climb at a rate of 2,500 miles per day, okay, so that is their rate. So we have a distance and we have a rate. So about how long will it take them to climb the Mount McKinley? So we have a D and we have an R. What we're missing is the time. So what are we trying to solve for? How long to climb Mount McKinley? Okay, so that's what I'm trying to find. My strategy, I'm going to use this DRT. I'm going to use a formula to help me. So I don't have enough room to write it all in there. So my distance, I understand it to be 3 and 848 thousandths. I know my rate is the 2,500ths miles per day. Okay, so every day he goes 1/4 of a mile. That's crazy. And then the time is our unknown. That's we don't know, so that's our question mark, our variable we're solving for. In the question it says the word about, so to me that says we can estimate. So let's go ahead and estimate this distance. So how would you, it's supposed to be a squiggle, okay, so 3 and 8/10 is pretty close to 4. So since we rounded up on our distance, our answer is going to be a little bit high. But it says about, so I think we can go with it. So, distance equals rate times time. So our distance is about 4 equals our rate, and then our time is our unknown, so we use the variable t. Now I don't know how much you've done with one-step equations. It is a 6th grade standard, so hopefully you've seen this before. But it says to multiply, and when we do one-step equations we do the opposite. So we need to divide by 25 hundredths. Divide by 25 hundredths. So on your own, I'd like you to take 4 divided by 24 or 25 hundredths. So what would that look like? That's my crazy decimal. Alright, so try to do that division on your own. Okay, so here's what my workspace ended up looking like. Sorry, I'm not very good with my pen, but I needed to take 4 divided by the 25 hundredths. So 4 went inside the box, I moved my decimal, divided it out, and got 16. So 16 is a little high since we rounded up at the beginning there, but I went ahead and took that. So it will take about 16 days for someone to climb Mount McKinley if they cover a quarter a mile per day. So pretty awesome. Happy climbing.